All right, so we're getting ready to review for our Unit 2, Topic 1 assessment. This first few questions, you're dealing with this scenario. You're saving money for a video game system. You have $100 already, and you can earn $20 per hour as a tutor, right? Fractions of hours will be multiplied by the $20 rate. What that means is that you don't have to tutor for whole hours. You can tutor for a part of an hour. And you have no more than 18 hours to spend tutoring. So H, here's our let statement. Let H represent the number of hours and M of H the total money. So is the variable H, our hours, continuous or discrete? Well, remember, continuous means there are no jumps, that everything is connected. And discrete is when you have separate, individual, countable numbers of hours. And in this case, we are definitely a continuous function, or a continuous variable here, H. It's continuous because of this statement that says that fractions of hours will be multiplied by the $20 rate. So what that's telling us is we do not have to tutor for entire 1 hour at a time. Okay. We can tutor parts of hours or partial hours. So what is the domain and the range? Well, because we have just said that H is a continuous variable, our domain will be done in an inequality, in the form of an inequality. So the least amount of hours that I could tutor would be 0, and the greatest amount of hours would be 18. No more than 18 hours. So from 0 to 18, we're talking about the hours, so that's the variable H. And then we just have to decide, can we actually tutor 0 hours? Well, yes, that would be a possibility. And could we tutor the entire 18? Since it says no more than, not more than 18, we could still do 18. So include that one also. This is your domain. Your range would then be the least amount of money you could have and the greatest. So the least amount would be if I tutored for 0 hours. Now, that's not $0 though, because remember, you already have $100 now. So the least amount of money that I could have would be $100. I already have that. And then the greatest amount would be if I tutored all 18 hours. So if I can make $20 an hour for 18 hours, 20 times 18 is 360. However, I already have that $100 too, so I have to add that onto it. So that means 460 is the most I could have at the end of this tutoring session. This is the range, so we're talking about M of H. And yes, we can actually have $100 if we don't tutor at all. And we can actually earn exactly 460 if we tutor the maximum amount of hours. All right, so now we're presented with the equation, the function rule here, 20H plus 100, which is, a formula that we just applied to the 18. That's how we arrived at the $460 possible money. Using the function rule, complete the table and sketch a graph. So notice in this table that there is one value suggested that's a decimal. That also hints at the fact that these other ones might be decimals too. So in order to fill this in, and again, you're welcome to use your calculator, but you might not find both of these M of H or these Y values in the calculator if you just put the equation in Y equals, okay? Because they might have decimal numbers for H. So if I substitute 1 for H, that means 20 times 1 plus 100. And you don't have to show that work in the box here. I'm just showing you where I'm getting the value, but that's 20 plus 100. So 120 is the number you would want to see there. If you tutored for 4.5 hours, it means $20 an hour for 4.5 hours. Add on the $100 you already have. So 20 times 4.5 is 90, plus 100 is 190. And let's do the other one where we have the X or H value. So 20 times 12 hours plus the $100, that would be 240 plus 100, so a total of $340. Now, if we're given the money value and we have to solve for the H value, that means you go to your equation, M of H equals 20H plus 100, and you substitute the desired dollar value for M of H, and then you will be solving for H. So you'll subtract 100 on both sides, leaving you 120 to earn. Divide that by the $20 per hour. We find out that takes 6 hours. And one more. If we substitute 280 for the money, subtract 100 on both sides, means we need to earn 180 by tutoring. That's done $20 per hour. So that one takes 9 hours. Okay, so I need to go over here to my graph and use those values sort of as a helper to help me decide what I should count by. So, well, actually, I guess our domain and range from the last page would be an even better indicator. I believe this grid here is a 20 by 20 square. So for the hours, we said our domain was from 0 to 18. So if I count by ones, I should get to 20 there. So 2, 4. And for the money earned, we said our range went from 100 to 460. So if I need to get to 460 and I have 20 boxes to do it, in my head I'm saying, or asking myself, 460 divided by 20 would be 23. Well, I don't want to count by 23s, but I could count by 25. So 25, 50, 75, here's 100, 2, 3, 200, 300, 400, and 500. Okay, this is our graph of saving for the PS4. So we can plot only these 5 and then decide whether it's continuous or discrete, or we can go to the table in the calculator to come up with even more values than this. Let's see what we have here. So our first point would be 120. Then we would have 4.5, 190, 6, 220, 9, 280, 12, 340. That would be 340 would be closer to here. Okay. Now, that's just the 5 points that are in the table on my worksheet here. But we know there are more possibilities. There's infinitely many possibilities here. So what we want to do is graph all of them, meaning we want a continuous graph. Now, I don't just want to connect the points that these 5 points, but I need to think about my domain and range. There was a value for tutoring 0 hours. There was a range value there, and it was 100. So that's actually the lowest point on my graph. And then the maximum, if I tutored all 18 hours, that would result in $460. So I want to put that point, and then I can connect these. It would be passing through all of the ones I have in my table and many more. What you do not want to do, though, is forget that it's continuous and forget to connect them. You do not want to only connect the 5 points in your table, because that was just a sampling. And you should not continue the graph beyond 0, 100, and 18, 460. We already said on the first page that our domain and range only covered those values. So if you extended the line beyond there, or if you drew arrows on the end of the line, then you've actually given me an incorrect graph. So are there any intercepts on your graph? Why or why not? Well, we do have one. We have a Y-intercept, or in this case, I guess it would be called an M of H intercept. And it stands for when we didn't tutor at all. So let's get this on here. Are there any intercepts? We have one Y-intercept at, it's the point 0, 100. And why or why not? Well, the reason we had this one was we can tutor 0 hours and still have the $100. Now, why are there no X-intercepts? Well, to have an X-intercept down here would mean there's a certain amount of hours I could tutor and have no money. But that would never be the case, since we already have $100. We will never, we will never have $0. Therefore, there are no X-intercepts. Okay, the important part would be to say this, to identify the intercept that you do have and tell me why. Becomes even a better answer if you explain, though, why there are no X-intercepts. Is the function increasing or decreasing? Well, it's definitely increasing. And again, we started with $100. Then earned $20 per hour. We never lost money throughout the problem. Okay? All right, so we're done with the PlayStation problem and moving on to a situation here where crumbs in Mr. Jackson's beard is a function of time. Of course it is. So we are to assume there are 8 crumbs at time 0. All right, so that would be the Y-intercept. All right, the 0th term. The number after m minute, or the number m minutes after time 0, is given by this function. Okay, so crumbs in relation to minutes is 8. Again, there's our Y-intercept right in the front, times 3 to the m. So the 3 must be, since this is it's multiplication, it's an exponential function here. It's in the form a times b to the x. That b we know is the multiplier. So that means our common ratio, our multiplier, is 3. Okay. So C of 4 means we want to substitute 4 for m. Okay. So that means we want to evaluate C of 4 by substituting 4 for m. And remember, by order of operations, you need to do 3 to the 4th power first. So that would be 81. So we have 8 times 81. 8 times 81 is 648. 648. So what does C of 4 represent? Well, C of 4 we just said was 648, so it means there are 648 crumbs in the beard, but it represents at 4 minutes. So at 4 minutes. Okay, so Mr. Jackson shampoos his beard when the number of crumbs hits 472,392. So when would that happen? Now that is really, because that's a very high value, you're not going to know what power of 3 is equal to some gigantic number there. So it really becomes either a calculator or a guess and check problem. So you can either put this equation in your graphing calculator, then go to the table and just look for this value, 472,392, for a y value. Now to actually solve this, you would have to substitute that for C of m, and then try to solve the equation for m. The first step there would be to divide by 8. So 3 to the m equals, let's see, 472,392 divided by 8 is 59,049. But like I said, you don't know which power of 3 equals 59,049. So what you would want to do is either guess and check right from the beginning with the full equation trying to hit 472,392, or you could, if you solved it down to this step, then you could see which power of 3 would equal 59,049. So let's see if I can find that here. So it's 10, okay? Since 3 to the 10th equals 59,049, it's 10 minutes. Now notice this question doesn't ask for any explanation whatsoever. It just asks you to tell the time. So it is 10 minutes. If you did it with your calculator, did it by guess and check, set it up and tried to solve, any of those are fine as long as you ended up with 10 minutes. Okay, we have a graph there. We just need to know, is it a function, and tell me the reason. So remember, when we're looking at a graph, the simplest way to tell whether or not it's a function is to use the vertical line test. So if we just take a vertical line and pass horizontally across that graph, we would never intersect at more than one place on the graph. So that means it passed the function test. It passed the vertical line test. So yes, this is a function. Now the reason, whenever we determine that something is a function, the reason is always exactly the same statement. You just repeat that definition. You don't need to mention the vertical line test, but our definition of a function is that each domain element is paired with exactly one range element. All right, and finally this back page here. We're going to use the three functions named f, g, and h. One's a graph, one's a table, one's a formula, an equation. We're going to use those to answer all 5 questions on the back page here. Please make sure you don't try to rush through this. Don't try to guess by glancing at it. Now I can see a lot of values on the graph. I can see values in the table. The equation doesn't show me any values. So the first thing I would do with something like this is make myself either a table or a graph, maybe both. Maybe put it in your calculator and you can jump back and forth between looking at your table and looking at your graph. But for this formula, 3 to the x, I just need a sampling here. 3 to the 0 is 1. You know, anything to the 0 power is 1. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. And 3 to the fourth is 81. I may need different values from what I see there, but it gives me that idea of what I see going on here. So, which has the greatest or the largest value? F of 6, g of -1, or h of 3? That is not something you can answer by looking at one thing, looking in one place. You need to go find all three of those values. So, f of 6, I would go to the f function, this first one on the graph, go to where the x value is 6, so 1, 2, 3, 4, 5, 6. And my point is right there. So f of 6 is 0, right? The 6 in the parentheses is always your x value, and then what it's equal to is your y value. G of -1. So I go to the g function, go to where x is -1, and you see it's equal to 2. Right? That's the x, here's the y. And h of 3, since the 3 is the x value, I go to my h function, where h is 3, and I see it's 27. So which one of those has the greatest value? And definitely it's the h of 3 is the greatest value. So the way I would like you to do that is actually show me, write down all three of those values, and then just indicate by circling or repeating which one is the greatest. So which has the smaller value? The y-intercept of f of x or the y-intercept of h of x? So let's go find our two y-intercepts here. The y-intercept for f of x over here is 1, 2, 3, 4, 5. So for this one, it's -5. For h of x, the y-intercept, that's when x is 0, is 1. So for h of x, it's 1. So which one has the smaller y-intercept? F of x has the smaller y-intercept. Let a, b, and c be numbers such that. Now this is the one people usually have such a hard time with. We don't know a, b, and c. They are the x values that result in these indicated y values. So meaning, if I want f of a to equal 6, I need to go to the f graph and find where the y value is 6. So 1, 2, 3, 4, 5, 6, and then say, oh, what x resulted in a point that is up 6? Well, it's this one over here, so that's 1, 2, 3, 4, 5, 6, 7, 8. It's this point, which is -8, 6. So a is -8. Right? The x value that results in a y value of 6 is -8. So I go to the g table and I want which x value has a y value of -7. So I'm not looking at this one. No, no, no. The y value has to be -7. So b is 5. And lastly, for the h function, again, I want the y value to be 9. So I'm not substituting 9 in and doing 3 to the 9th. I already have it in my table here. The y value is 9 when x is 2. So c is 2. And then I need to add a plus b plus c. So -8 plus 5 plus 2. -8 plus 5 is -3, plus 2 is -1. Okay. Which function is decreasing? So that means going down, getting lower, on the interval from 0 to 5. I want decreasing, just interested in the part 0 to 5. So 0 to 5 on this one is when x is 0 to 1, 2, 3, 4, 5. I'm only looking between these two dotted lines. Is that graph decreasing? No, it certainly is not. On this function, now I know 0 is not in the table, but 0 happens right here between -1 and 1, and I'm going to, when x is 5, is that decreasing? -1, then -4, then -7? Yes, it is. So it looks like g of x is going to be my answer. Let's look at the last one just to make sure. And again, from 0, the beginning of my to 5, now I didn't include 5, but I can already see this one is going up. It's not decreasing. So definitely g of x is the only one where the values went down as you looked at the x's from 0 to 5. And this last question, what is the value of f of -3 times g of 3 times h of 1? That, again, you got to remember to get this right, that it's the x values that are given to you in those parentheses. You're looking for the y values. So f of -3 means I go in this graph, when x is -3, that's 1, 2, 3. The y value is 1, 2, 3 down, so it happens to also be -3. Coinky-dink. G of 3, g of +3, means I want to go to where the x is 3 here. The value is -4. And h of 1. So when x is 1, I get a value of 3. Now, for this question, I'm supposed to multiply those three values. So -3 times -4 times 3. -3 times -4 is 12, times 3 is 36. Please indicate each one of those values, because if you get even one of them wrong, this number's not going to be correct. But that doesn't mean you can't earn partial credit for getting one or two of the three function values correct.